Hi guys, welcome to the Pepcoding. In this video, we are going to solve Sieve of Eratosthenes. So, in this question, we have given a number n, and we need to print all the primes from 2 to n. And this problem should be solved in the complexity less than n root n. So, we have to solve this in n less than n root n. So, in level 1, for finding any number for prime, we have done in complexity of n, and also we have also done it under root n to find a number. If let's say we have a number, if we have a number 11, the time complexity for finding this we have done in under root 11 and also for 11. So we have done this in level 1, but in this question, this is a sieve of Eratosthenes. Uh, this is an algorithm to find prime numbers in less complexity. Let's see. Let's say we have number of queries like Q queries, and these queries have numbers 1, 2, 2, 3, 10, 10, 100, 100, 1000, 1100. So there are some queries, and for finding all the numbers is prime or not. Here, if we find for this, it will take under root n for this 2. For finding 10, it will take under root n. For this 10 also, the numbers can be same. For this also, it will take under root n. So overall, if we see, if we have q queries, each number take under root n complexity to check is it prime or not. So this will take q into under root n complexity to find the number is a prime or not. And in this sieve of Eratosthenes, we will solve it in less than q under root n. How? For this, for solving this in less complexity, what we need, we will do pre-calculation of the range we have given, range n, and we need to print from 2 to n. So we will do the pre-calculation from numbers 2 to n. And when the queries having numbers 1, 10, 100, and like all 1000, we can give the answer of this one or this 10. This is also 10. This 10 in of one complexity to check is it prime or not, because we have already done pre-calculation of all the numbers if the range is from 2 to 1000. Now let's see how will we do pre-calculation of these numbers. So let's say we have a range n is equal to 37. So for checking the range from 2 to 37, we will use bool array, or in this C++, I will use vector of bool. What will be the size of this? This will be is prime. What will be the size of this is prime vector bool? So the size will be, we have given n. So the size will be n plus 1. Why? In array, if we give a range of array is equal to 10, it will take 0 to 9. But in this we have given a range 37, so it will take 0 to 36. But this 37 should be include also. So for this we need to increase the range of this. The size of array will be 37 plus 1, that is 38. So it will go from 0 to 37. So we can check 37 also, is it prime or not. Now let's make the all the numbers of boolean here: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the 10 numbers. 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. Then 21, 22, 23, 24, 25, 26, 27, 28, 28, 26, 27, 28, 29 and 30. Then 31, 32, 33, 34, 35, 36 and the last one is 37. So these are the numbers. Initially all the numbers are true. This means initially all the numbers are prime. These all are true. We will use these. We will use this to find all the numbers are prime or not. This is also true. Now these all are true initially. Except these two. Except these two. We will start our loop from 2 to n. Now for this 2, initially it is true, so 2 is a prime number. Now if 2 is a prime number, this means the multiples of 2 will uh, will not be a prime number. So this means all the numbers we have made true of multiples 2, we need to make them false. We need to unmark them. So the multiples of 2 will be unmarked. So for unmarking, we will start a loop from the I, that is 2. 2 plus 2, here 4, from 4 it will check, it is 2, it is divisible by 2 because this is a factor of 2, multiple of 2. So we will unmark all the numbers of the multiples of 2. So all the numbers will be marked as false. 24 also false, 26 false, 28 false, 30 false, 36 false, this false and this false. Now the loop will go to the next value, which is 3. Now from here it will check 3 is true. This means 3 is not a multiple of previous one, any numbers of the previous one except 0 and 1. So this means 3 is true. So multiple of 3 should be unmarked because all the numbers which are multiple of 3 are not a prime number because 3 can divide them. So we will again false all the numbers of the multiple 3. So 6 is false, 9 false, 12 is already false, 15 false, 18 already false, 21 false, 24 false, 27 false, 30 already false, 33 false, 36 already false. Now our next element is 4. So 4, here 4 is already marked as false. So this means 4 is a multiple of any number of the previous one which are prime. This means if 4 is the multiple of 2 and 4 is false, this means all the multiples of 4 will also be false because they are also the multiples of 2. So we do not need to iterate for all the values till n for the 4, because if 4 is already false, this means all the multiples of 4 will be already false. Now it will go to 5. Now 5 is true. 5 is true. This means This is a prime number. This is a prime number. Multiple of 5 will be, again all the multiples of 5 will be unmarked as false. So 10 is already unmarked. 15, 20, 25, 30, 35. Now our element is 6. Here again we can see 6 is already false. This means the multiple of 6 will be already false by the previous numbers which are prime. And here 3 is 3 is the 6 is the multiple of 3. This means 3 already have false all the multiple of 6. So we do not need to iterate for 6 to unmark all the multiples of 6 because they are already unmarked. Here 6 is unmarked, 12 is unmarked, and 18 is unmarked, and 24 is unmarked, 30 is unmarked, 36 is unmarked. Now we will go to the next. Next is 7. 7 is already true. This means we need to unmark all the numbers which are multiples of 7. So here the multiples of 7 are 14 already unmarked, 21 already unmarked, 28 already unmarked, then 35 already unmarked. Now it will go for 8. It is already unmarked. This means it will go for the next value. Here 9 is already unmarked. It will go for the next value, that is 10. So outer loop will be run till under root 37, because we do know the factors. If 36 having factor 2 into 18, this means 18 into 2 is also a factor. So here 3 into 12 having the factor 12 into 3. So this means we do not need to check for all the numbers from 0 to from 2 to n. We have already know how to find the number is prime or not using this condition for the for loop, that is under root n. That is under root n. So outer loop will go till under root n, and the inner loop will check for all the numbers if they are prime, like 2 is a prime number. So it will go from 4, that is 2 plus 2, and it will check for all the multiples of 2 till n. So now we have all the array, and all the array, all the indexes of the array tells the number is a prime or not. Here 22 is not a prime number, 17 is a prime number, 19 is a prime number. Here 24 is not a prime number, 35 is not a prime number, 37 is a prime number. So we have already pre-calculated all the numbers are prime or not. Now we have few queries. If it will ask for all the numbers, like we have the range n, so it will ask for 2 to 37. We will directly start our loop from 2 to n, and if the boolean at 2, the array is prime at 2 is true, this means we need to print the 2 value. If 37 is true, we will print that value. If 35 is false, we will not print that value, because 15 is false. We will not print that value because 15 is not a prime number. So this is the pre-calculation of the numbers from 2 to 37. So let's code this. Here what we need, I'm going to use vector of boolean is prime having range n plus 1, and initially all are true. Now we will start our first loop from I equal to 2, I into I is less than equal to n I plus plus. Now we will check if is prime at I is equal to true. This means we need to unmark all the factors here. Unmarking all the multiples of I, which is the number. For that, our loop will start from j is equal to I plus I. j will go till n and j plus equal to I. Here we will unmark is prime at j is equal to false. So we have pre-calculated. This is the pre-calculation of the prime numbers from 2 to n. After that, we have already pre-calculated all the values. We just need to start our loop from 2 I less than n I plus plus. If is prime at I is true, we will print I. We need to print that number if it is prime. At the end, there is nothing. We have already printed all the values from 2 to n if it is prime. So this is the code. Let's run this. So here we have given n is equal to 10. So range is from 2 to 10, and we have the answer from 2 to 10 is 2, 3, 5, 7. These all are prime numbers. Now let's submit this. So all the test cases are also passed. Now let's take this code to the open board to check the time complexity, how it is less than n under root n. Now the outer loop is running. This for loop is running. It will take under root n complexity. Now for this inner part, let's check for this. When I equal to 2, the complexity will be n by 2. When I is equal to 2, the complexity will be n by 2. We are taking the jump from n, then n plus 1, from j plus 2, then j plus 2, then j plus 2. Now when I is equal to 3, it is also true. It will take n by 3 times. I is equal to 4. Now at this time, I is equal to 4. This will be already unmarked. This is unmarked as false because it is the multiple of 2. It is a multiple of 2. So this means this will be this condition will false. So this inner for loop will not work. It will take only of one time. Now I is equal to 5. This is true. It will take n by 5. Then I is equal to 6. It will also take 1 because this 6 is a multiple of 3, and 3 will already unmark this 6 by running this for loop. Now I is equal to 7. 7 is true, so it will take n by 7 time, and then it will go like this. When I is equal to n, it will take n. When I is equal to under root n, we are running our loop till under root n. It will take n by under root n. Now let's take this. The value will be like n by 2 plus n by 3 plus n by 5 plus n by 7 plus dot 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 plus n by under root n, the last value. Now if we solve this, it will be like n 1 by 2 plus 1 by 3 plus 1 by 5 plus 1 by 7 plus dot 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 1 by under root n. Now we have this value, and if we solve this part, this part, it will give us in log of n. This will be equal to log of n. If we solve this, and this is multiplied by n, so it is taking n of log of n times. Now let's say n is equal to 2 raised to the power 32. Here the basis of this log is 2, and there is a formula. There is a formula of log when log of a base and a of power b, it will be equal to b. This is a formula of log. We will use this formula to solve this complexity. Let's say this is 2 raised to the power 32 dn. Now log of 2 of log of base of 2 of 32. Here we can see it is equal to log of a raised to the power b. So this will change equal to 32, which is b. So this will be 2 raised to the power 32 log of 2 of 32, and we can change this 32 in 2 raised to the power 5. This is 2 raised to the power 5. So now it will be 2 raised to the power 32 log of 2 of 2 raised to the power 5. Here again the base is 2 and this is also 2. It will be 2 raised to the power 32 into 5, where 2 raised to the power 32 is n and 5 is the constant, let's say k. If we find the complexity in O, big O of this complexity will be O of n to check all the numbers is prime or not, and for all the numbers, the queries, n number of queries, it will take O of one time. It will take O of one time to check is it prime or not. Is prime or not. If it is prime, we will print. So here we can see it takes less complexity than n under root n. It is taking O of n, where it have done the iteration of n k times, where k is in range of 1 2 3 4 5 or like this. And when we want the number, is it prime or not, it takes only of one time to check. So we have reduced the complexity of finding prime, and this is the Sieve of Eratosthenes algorithm. It reduces the prime to check the prime numbers in less complexity. So this is the code. Hope you understand the code and the concept. We'll see you in the next video. Thank you.